Hi, I'm Christian Delfino from Roland's Professional AV Division. Good morning from our studios here in Los Angeles, and a big welcome to everyone who's joined us from around the world for our webcast launch of the V-1200HD multi-format video mixer. Now, Roland is a veteran in the video market. Our first product was introduced all the way back in 1994, which was an ISA card that you put into your computer to capture video for editing. Now, since then, we've come out with standalone video editors, video presentation products, broadcast standards conversion, as well as an incredible lineup of video mixers and switchers. In fact, we are almost near 100,000 video mixers and switchers sold. Quite an incredible legacy. Now, when we take a look at the mixer and switcher market, you can basically take any mixer that's in the market and put it into one of two categories. Either it's designed for broadcast or it's designed for live event. And of course, the needs for both of those markets couldn't be any more different. If you're taking a product for broadcast, of course, you're going to prioritize an SDI workflow. Lots of SDI in, lots of SDI out. You're also going to need lots of different keyers, so to create different layers and compositions. And ideally, you also have a couple of MEs so you can create multiple programs and to be able to switch between those to create really professional broadcasts. Now, switch over to the live event market. That one, of course, we're going to have lots of computers, lots of video playback that's going to come in to the system. We're, of course, still going to mix it with cameras, but we're going to need scalers and other things to make sure that that high-resolution computer graphics come in, are able to mix with the video, and go out at a really high resolution to new displays like LED walls and high-resolution projectors. Of course, portability is a key issue, and we need lots of different connector types because we never know quite what's going to be at one event to the next. Could be SDI, could be DVI, could be HDMI, who knows. So today we are really excited to introduce to you the V-1200HD multi-format video switcher. It has all the features that you need to produce broadcast productions or live events without compromise. Here's a short video to introduce it to you. As you can see just from that teaser trailer, this is quite the product. Now, the V-1200HD consists really of two products. There's the V-1200HD multi-format processor, which is in this rack mount chassis. All of the video I/O processing is done right here in this unit. And then the V-1200HDR. This is the control surface for the V-1200HD, and it connects simply through a Cat5 cable between the main unit and the V-1200HDR. Now, what's unique about the V-1200HD is an entirely new engine that is totally unique that Roland has developed that takes the best of the broadcast switching world with a 422 mixing engine and marries it with the best of a live event presentation and processing engine, which is a full 444 mixing engine. So once we take both of these together, we can create both that broadcast mix and that live event presentation mix out of the same switcher. So let's start with the 422 mixing engine. And what we'll do is we'll take a look at an image of the back of the V-1200HD, and we'll take a look at the inputs that are directly connected to the 422 mix processor. So you can see on the back, lots of SDI, perfect for broadcast. Now, you have 10 SDI inputs. These are capable of everything from 480i all the way up to 1080p, so they are 3G SDI. And then you can see that we have 6 SDI outputs, again, 480i all the way up to 1080p 3G SDI. Also, in addition to that, we have 2 HDMI inputs, because there are going to be some data sources, or maybe you have 1 or 2 HDMI cameras that you would like to connect. And then also, we have 2 expansion card slots, and these will give you up to 2 additional inputs and 2 additional outputs. And we can discuss those in more detail in a moment. So let's go into detail about the 422 engine. Now, the 422 engine is a 2ME engine, and there are multiple modes that you can select for the MEs. There's 2ME, 1.5, and 1ME. So if we take a closer look at the 2ME, you can see here that we can create 2 independent programs from each ME. And both MEs both support 2 layers, so 2 keyers can be used on each ME. Now, in addition to that, we also support re-entry of ME1 to be used as a source for ME2, but also we support re-entry of ME2 back into ME1. So very powerful switching capabilities built into the 2ME engine. Our next mode is 1.5ME. Now, when using 1.5ME, all 4 keyers are used on one of the MEs, allowing us to create some very powerful, very rich compositions. The 1.5ME is then available as a re-entry into a program preset bus, and you can switch a single source from the 1.5ME to a single source on the program preset bus. So again, another workflow application that you're capable of doing. And then in addition, we have 1ME. Now, all 4 keyer layers are used on the 1ME, and in addition to that, we have 2 aux buses that become available for you to send independent outputs wherever you need them to be used in your assignment. So very straightforward mixing style, but very powerful with 4 keyers included. So let's take a closer look at the 1.5ME mode and just demonstrate the re-entry capabilities that's in the V-1200 HDR. First of all, let me give you a quick overview of what we have set up here today. So we have 12 sources plugged into the V-1200 HD. We, of course, have the V-1200 HDR acting as our control surface. We have our 16-split multi-viewer set up here. And then we also have a direct output of ME1 from the back of the V-1200, and then ME2. And that just makes it easier for you to see, as we do switches between each ME, how those happen. So, of course, if we go to the V-1200 HDR, we have our program and our preset bus here, our delegation bus is here, and then the ability to select which ME that I'm currently switching between, so ME1 or ME2. So let's start with setting up ME1 to be able to do the switch. First of all, go into the V-1200 HDR interface, and this interface is actually brilliant. It's designed so anyone who's even a very experienced video operator can get on here and really appreciate the detail that's been put in, but it's also very, very clever that what the engineers have done is used the block diagram as your navigation system. All you have to do is follow the signal flow through the V-1200 HDR screen to see exactly what you're looking for. So in this case, I'm looking for what my ME setup is, and it's right here in the center. So I'll just select that. I have multiple MEs that I can choose, and as you can see, this is, of course, a touch interface that I'm able to use. And what I'm going to do is set up a composition and make sure that that's turned on so I can use that in my first ME. So I'll go to Composition, and I'll go to Edit, and I'm just going to make sure that the picture-in-picture is enabled. And now you can see that showing up in the ME1 output. If I want to change what is assigned to that picture-in-picture, I simply choose it here on the delegation. And what I'm going to do is have this video playback come in as the picture-in-picture source. Now, to change the picture-in-picture, it's actually really nice. You just grab it here on the touch screen. You can move it around where you want. Now, of course, you would do this all in your preset bus just to make sure, your preview, just to make sure that everything is squared up and not bring it live like we're doing here. But this really makes it easy for you to see. I can also adjust the size there just by adjusting these. Of course, I could go over and use my positioner section if I want to use a more traditional way of doing picture-in-picture. But here you can see a really clever way to use the touchscreen interface that's built in here. So now I do have that first composition set up, and I'll go through and turn on my second one that we can do here. Go to composition 2, and we can change that to a second input here. And let's move that somewhere that's out of the way up over here. So really, this is just a demo to show you as opposed to a practical example, but just to show you what would happen if we were to put two picture-in-pictures up on the screen using the keyers that are included here. Now, those are all set up and ready, and that's my ME output 1. I'll switch over to ME2, and you can see here that re-entry is assigned into a crosspoint number 15. And to do that, just to make sure it's there, I can go into my patch bay here, and you can see program 1 is now patched to the re-entry section. And then all I have to do would be to go into my crosspoints and make sure that re-entry is assigned to one of the crosspoints. In this case, it's number 15. So really, really simple. And again, just use this block diagram type interface to follow where you want to go in your signal path. It's really quite clever and makes it really, really easy to use. So now that I have ME1 showing, I have now on ME2, and I want to bring this up in my preview. And I've actually assigned here, labels are coming for this, still in development. But here I have my preview bus set up for my second ME, and I can just cut on my second ME and make that a source. So switching between a fully composited source created in ME1 to a single source on ME2. And that's how we use the re-entry bus on the V-1200HD. Now, let's move over and talk about the next part of the engine that's part of the hybrid engine, and that's the 444 process. Now, what is the difference between 422 and 444? Of course, we are talking about chroma subsampling, and we actually did a video a couple of years ago when our V-800HD came out, and that one is capable of supporting 444 processing as well. So let's take a quick look at that so you can see exactly what the difference you're going to get between 422 and 444.
Today I wanted to show you a real practical difference between 444 video processing and 422. Now what do those numbers really mean? Well, it really refers to color or chroma sampling, how color is sampled within a particular video signal. And the reason why compression even exists is to really make the data required, the stream required, a little more compact, a little less bulky. So what scientists are able to do is actually compress color in different ways that the eye couldn't really detect very well. So in fact, our eye actually detects changes in brightness, luma, in other words, much more readily than color. So usually we don't compress that part, which is the first number, the 4, but the other colors we can actually compress and get away with it, especially in the video world. Where you can't get away with it as readily is when you're using computer inputs. So today I want to show you some practical examples of how it really makes a difference in real life. Instead of showing charts and diagrams, let's take a look at a test pattern as well as a real life example from a spreadsheet. So the first pattern we have here is a 1920 by 1080 image, and it is got red, green, blue lines in sequence that is very hard for chroma sampling to sort out. What we've done is we've connected a little USB digital microscope here that's looking at the pixels at about 200-300 times magnified, and we're running that through the switcher again, and we've actually put it into a picture-in-picture. So you can see roughly here we've got the red, green, blue, nicely organized into lines. Now let's go, and this is at 444. Now let's go and change to a 422 processing. You do that in the system menu, color space, changing it to YCC. And when you do that, you can see that the pattern changes significantly. You've got a mixture of red, green, some black, and then some repeats, blue and green. It's not a lot of clarity there. So you can see quite dramatic. Let's go back one. This pattern versus this pattern. So let me pull up now an example of from a spreadsheet. Here we have a spreadsheet with a blue-red background, and it's currently running through at our typical 422 processing from the computer. Let me pull up the picture-in-picture again, magnifying up that text. You can see both with the zoom up as well as with the microscope, you can kind of make the numbers out, but they're a little hard, and hopefully it's coming through on the video here. But you can definitely see degrading of the numbers around that, and that's because the color sampling is such where it can't really do that level of detail too well. So let's switch to 422 and look at the difference here. So now you see a much greater clarity with no problem with all the numbers. You can see all of the clarity around the edges, and this is zoomed up high. And if you're looking with the naked eye right in here, you'll be able to see that it's very sharp and just as clear as the white numbers are. And you see that there's no problem with black and white because it's all luma sampling, which in the 422 space has no degradation. But as soon as you have blues and reds and greens, then you get that problem unless you're running at 444. So there you have some examples that really show the difference between 444 and 422. I think the differences are quite dramatic.
So there is a clear difference between a 422 process and a 444 process. If you're doing anything with data inputs or computer resolutions, you're going to want to use the 444 process. If you're going out to an LED wall or a high resolution projector, you're going to want that pixel accurate color from your computers to be maintained throughout the signal chain from start all the way to finish. So let's take a closer look at the 444 switcher and processor that's built in here to the V-1200HD. So the 444 section is right here, and there's 4 sources that are available to the 444 engine. 2 of those are going to be assignments that you make from the 422 engine. So to do that, I'm going to go into my patch bay, and those are known as S1 and S2. And you can see down here the side, and depending on which type of ME I've selected in my 422 engine, I can send program out, preview out, clean feeds, any one of my compositions. If I have aux buses, I can assign those. So really any output path can be assigned and used as a source into that 444 engine. Now, we also have HDMI 3 and 4 on the back of the unit. There's a total of 4 HDMI inputs. HDMI 3 and 4 also have scalers, and they can be routed as your 3rd and 4th input to the 444 processor. So once you get there, you now have 3 different modes that you can use with the 444 process. Let's take a look at those. First of all, we have a scalar mode, we have a matrix mode, and we have a self-key mode. The matrix mode is one of the most common ones, and it's going to take your 4 sources and give you a 4x2 matrix output. So simply hit on the 444 video ME, and up pops your matrix switcher. So here you see your 4 cross points, and you can adjust those as you want, and your output to HDMI 1 and your output to HDMI out 2. And both of them are going to have the same resolution, and you could choose any standard video resolution, but you can also do data and computer resolutions very easily as well. And that's the advantage to all the scalers that are built in here. There's actually 4 scalers going in and 2 going out on the 444 engine. Let's take a look at the next mode, and that one is the self-key. So in the self-key mode, what happens is I get the cross-point switcher. So really, both HDMI outputs are going to get the same program, and then I can add a luminance keyer over top. So say, for example, I took my ME1 and ME2 program outputs. I could use that as a cut or a switch between those, and then also add a ticker or a crawl at the bottom of the screen to give me news information, news feeds, stock tickers, whatever you want to the bottom. That's one application, or you could bring up an additional lower third or something like that for your live event application. The possibilities are quite wide as to what you're capable of doing with that mode. Now, the third mode that we'll talk about is scalar mode. And with scalar mode, what happens is your HDMI 3 and 4 become directly connected to the 422 engine, but their scalars remain available so that you can input data sources that are not of the same resolution that the switcher is set to. The two remaining inputs to the 444 engine, which are really your two remaining outputs from the 422 engine, they get fully scaled and can either be output to two different screens independently at different resolutions, or you can scale them the same and do a span screen, for example. So you can take single content, spread it across two screens of really any aspect ratio that you want. So if you're creating some really crazy aspect ratios with LED tiles or something like that, the V-1200HD is fully capable of supporting that from the outputs of the 444 process. So you can see that when you take the combination of what's possible with the 422 engine and the 444 engine and all of their different modes together, you can very quickly get to lots of different multiple screen applications. You can create some great broadcast content and web stream that, broadcast it on television, record it, and also provide incredibly detailed, rich, super high resolution support to a live event that you might happen to be doing. And that's all thanks to this brand new, unique hybrid engine that Roland has developed for the V-1200HD. In addition to being a very powerful video switcher, the V-1200HD is also an audio powerhouse as well. So first of all, let's take a look at the back and look at all of the different audio I/O that is capable with the V-1200HD. Let's start with the XLR inputs and outputs. So if in analog mode, the XLR inputs and outputs act as a stereo pair of analog balanced audio. If we switch it to AES mode, then we get two stereo audio in and out from AES EBU. If you take a look at SDI inputs 7 through 10, they support a full 16 channels of audio de-embedding each. And then taking a look at the SDI outputs 1 through 4 also support 16 channels of SDI audio embedding as well. Now you can see that we also have HDMI for I/O, and the V-1200HD supports the first two stereo channels off each of the HDMI inputs, as well as embedding of stereo audio onto the HDMI outputs, including the multi-viewer outputs that are available on the back of the V-1200HD. Now, in addition to that, we do have the expansion cards on the back, and the expansion slot will support up to an additional 16 channels of audio in and 16 channels of audio out. So that's a total of 92 in to 92 out. So let's take a closer look at how we use the audio capabilities of the V-1200HD. We'll do that by going into the menu on the V-1200 HDR, and you can see that, again, a representation of the audio block diagram is shown, showing our 92 inputs and 92 outputs. In the center of that is a patch bay that allows us to patch any input directly to any output, and I can also choose what I'm going to patch to. I could patch to my mixer or something like that if I want, very easily. And you can see that, sometimes squares can get really tiny, but there's intelligence built in here that as soon as you touch it, you get much bigger quadrants to make sure that you make an accurate selection right in there. So patch bay is there. In addition to routing the audio directly, we can also insert delay, up to 16 delays on any of those direct patches. So we have those here available. And then there is a 16-channel audio mixer that's also available. So any of those 92 inputs, you can patch directly to the audio mixer. On the audio mixer channel, every channel has 3-band EQ. There's a send to a reverb. There's also additional individual delay for each channel that's available there. And you can also have the audio volume follow any one of your video crosspoints. So if you want to do audio follows video, that's also a capability that's built into the V-1200HD. Now also, in addition to the main output, you can also have two aux outputs, and those can provide you separate audio feeds to go to talent or other applications that you might need additional audio. So very powerful audio functionality built right in here to the V-1200HD. So the audio and video inputs and outputs are already quite extensive on the back of the V-1200HD, but we've got a really exciting expansion card story with our XI series of expansion cards. And these aren't just extra video terminals, they really are video audio scaling and a whole series of input types and protocols that you've never really seen on a video switcher before. Now let's start with 3 new cards that we're introducing along with the V-1200HD. They are the XI SDI, XI DVI, and XI SFP cards. Let's take a look at each one of those in more detail, starting with the XI SDI expansion interface. So first of all, the XI SDI has 4 bidirectional SDI terminals. There are 2 scalers built into the XI SDI, and those are also capable of de-embedding or embedding 16 channels of SDI audio at 48 kilohertz. Now, these are configurable into video configurations of 4 in, 3 in, 1 out, 2 in, 2 out, 1 in, 3 out, or 4 out. So lots of different flexibility and capabilities with the XI SDI. The second card that we're introducing with the V-1200HD is the XI SFP expansion interface. And SFP stands for Small Format Peripheral. And we will be supporting such small format peripherals as SDI and also video over fiber using an SDI protocol. Now, the XI SFP is capable of supporting 2 video SFP modules. It is fiber module compatible. There are 2 scalar built in, and there's also 16 channels of audio embedding and de-embedding possible at 48 kilohertz. This one is also video configurable, again, with up to 4 ins to 4 outs or any combination in between. The third XI card interface that we're introducing with the V-1200HD is the XI DVI expansion interface. It has 2 bidirectional DVI-I terminals, and that will support HDMI, analog RGB, composite, and of course DVI-A or DVI-D. Now, there are 2 scalers built in, and it also has different video configurations. You can do 1 in, 1 out if you like, or 2 in and 2 out. And then we also support audio embedding and de-embedding, basically stereo in, stereo out of the XI DVI. So if you've been following Roland, you've seen us introduce the M5000 live digital mixing console. And when we introduced the M5000, we introduced 4 XI series cards. We introduced the XI REAC, the XI Dante, the XI Madi, and the XI Wave SoundGrid card. And we're really excited to let you know that these 4 cards are fully compatible with the V-1200HD. They will allow you to get 16 channels of audio in and out through these multi-channel audio protocols when using any of these 4 cards with the V-1200HD. And what's even more exciting is that you'll be able to use the audio embedding and de-embedding functions of the 3 video cards that we introduced today with the M5000. So you can now put these into the M5000 and use these as part of your audio workflow. And here's a diagram showing you all 7 XI series cards and their capabilities with the V-1200 and the M5000. And what a unique story that only Roland could tell, bringing professional audio and video workflows even closer together with these XI series cards. So with all of this audio and video power in the V-1200HD, we've actually made it really easy to control and make sure that you get an accurate switch for whatever broadcast or event that you're supporting with the V-1200HD. Now, there's actually 2 control interfaces available for the V-1200HD. We have either the V-1200 HDR that you've seen us use and showing you a couple other features so far, but we also have the V-1200 HD RCS, remote control software. And that's available for both Mac or PC. And one of the great things about it is that if you're using a Windows 8 Surface tablet, which is fully touch enabled, you can use a wireless control interface by connecting it to an Ethernet hub. And in fact, you can have up to 4 controllers available to a single V-1200 HD unit. So you can have multiple operators switching possibly different MEs, or one person working on the 444 engine and other people working on the 422 engine. So lots of flexibility and lots of possibility there. So in terms of control, let's take a look at a few more of the features that we've put into the V-1200 HDR. And by the way, these are carbon copied right into the software RCS. So the same functionality exists in both control types. So the V-1200 HD, you've already seen that we have 2 great touch interfaces that are available here. And these can, in addition to being the GUI interface, we also have 2 HDMI inputs on the back. And to those, you can connect the multi-viewer outs on the back of the V-1200 to be able to bring the multi-view up on either one of these screens. So you can see here down at the bottom, we have left LCD showing us that it's currently set for GUI. And then on the right LCD, we also have GUI. If we wanted to switch this to HDMI input 1, you would have the multi-viewer come up here. And here's a little picture just to show you an example of what that will look like when it's fully implemented. But you can see that if you have mobile applications, you don't have screens that you can bring with you, very quickly you can do all your previewing right on the HDR unit, which is a nice advantage and certainly a great option to be able to have. So in addition to the nice touch interface, one of the other features of the touch interface that I love is the touch and turn feature. So what I'm doing here is going into one of my SDI inputs, and I want to adjust the brightness on that input coming in. So all I do is select the brightness parameter, and then I can use the value dial here. Again, just touch and turn the parameter I want to be able to make that adjustment. Couldn't be any easier. Real straightforward and really simple. In addition to that, you can see that we have a scribble strip line on the top here that allows us to put labels of all of our different cross points that we have set up here. So across here, 16 cross points, program bus, preset bus, and again our aux delegation. And our cross points are fully assignable. So if you were in an application where you wanted to make sure that your computers were your first 4 cross points, you're certainly free to do that. If you prefer to have cameras, really mix and match your cross points in any order that you want on the switcher. So using cross points, again, we've already pointed out the ability to switch between ME1 and ME2 real simply. And then this is your delegation section, which use the delegation row up here. So composition 1, what is currently assigned to composition 1, what is currently assigned to composition 2 is there. 3 and 4, same thing. And then our aux buses, if we're using aux buses, you'll be able to do that. And then we have a really innovative feature, which are 2 user layer rows essentially, and if I engage those, you can see these turn to green buttons. Now to set up the user section is really easy. We just go to function section and function select, and I'm just going to choose one. And you can see that some of the options I have is the ability to select which of the PTZ cameras that I'm and which memory of that PTZ camera that I want to select immediately, and we'll show you that in a moment. Also, which still image that we have currently selected. You can have 2 still images ready and active at any time, and you can store 16 in the memory of the V-1200HD, and it's a non-volatile memory, so once you put them in there, it stays there even if you power it off. GPIO functionality, set up cross points for your 444 switcher. So lots of options that you can set up in your user row right here, and you can give them labels so you can know exactly what you're doing with those labels when you set it up. So very easy to be able to use. We just touched on real quickly the ability to do PTZ camera control. And we just go here into our remote camera section. We have the ability to control up to 4 cameras, and we can set 4 memory presets per camera. And to control those cameras, we can use the positioner section over here. So we have a joystick that we can use, and then also the Z control gives us the ability to choose between zoom and focus for that parameter right there. Now, as you've seen, there might be different screens that we want to get to real quickly. So if I'm in my 444 process and I'm in matrix mode and I want to be able to very quickly get to the matrix switcher, we have 4 screen layout buttons that we can set up here to give us 4 screen layouts that we want. So very quickly switch between your previews, switch between your matrix switch, all kinds of flexibility to set those up to be ready to go. And then, of course, we have our T-bar. That allows us to do very nice, smooth manual transitions between different sources. You have a number of different wipes, mix, cuts, FAM, NAM, and also push and slide DVEs that you can implement with the V-1200HD. So control of the V-1200HD very easily achieved either from the V-1200HDR or the RCS remote control software. So the last piece of the user interface that we like to show you are the multi-view outs. There's 2 multi-view outs available on the V-1200HD, one for the 422 process and one for the 444 process. So on the 422 process, you can see here the output with the multi-viewer that's behind us. We can do a 16 split multi-view, which is awesome to be able to get that many sources onto a single screen. If you'd like to edit the multi-view, simply go into multi-view edit, and you can see that you do have a choice of a 16 split layout. You also have 2 different 10 split layouts where your program and preview, if that's what you choose to assign, are on the top, or you can do program and preview on the bottom there as well. If we go to multi-view 2, we can take a look, and you can see that you can do a quad split. So your 4 sources that feed the 444 engine are there, or you can do things a little more fancy with your sources and then your output buses and things like that by using the 10-up outputs that are available for the multi-view on the 444 section. So the multi-view just uses HDMI output. Any standard 1080p monitor makes it very affordable for multi-viewing to be able to do. Simply plug it in and you're ready to go. So let's review the key features of the V-1200HD multi-format video switcher, starting with the audio and video mixing engine. Starts with, of course, the 422-444 hybrid engine. It contains a 422 process with selectable structures of 2ME, 1.5 ME, or 1 ME with reentry. Of course, up to 4 composition layers are possible. There's the 444 process with multiple modes of scaling mode, matrix mode, and self-key. Of course, the high quality scaling that's also built in to the 444 engine. This engine is low latency and it's also HDCP capable. We will be introducing 4K capability by future update, and of course the powerful audio engine with its 92 channel audio router, 16 channel mixer, and additional 16 channels of delay. Of course, all of this power has been made incredibly easy to use, and it also supports multi-operator capability with up to 4 interface connections. Of course, those interface connections can be the V-1200 HDR with its 2 large touchscreen interfaces and professional-grade hardware interface. We, of course, have the V-1200 RCS, that is both Mac and PC compatible, and in fact you can run it wirelessly by using a Microsoft Surface tablet. Of course, we've introduced PTZ camera control to Roland video switchers with now up to 4 camera control, and we're using the VISCA protocol to achieve that. Of course, the multi-viewer with its 2 multi-viewer outputs allowing you to do 16 split, 10 split, and 4 split combinations. So we are of course really excited about all the creative possibilities in the V-1200 HD. The V-1200 HD will be on display at the upcoming NAB show in Las Vegas and also the Pro Light and Sound show in Frankfurt, Germany. Our website will go live immediately following this webcast with all of the details and specifications of the V-1200 HD. And if you have any additional questions, please contact your local Roland representative. We'd like to thank you for joining us here today from our studios in Los Angeles, and we look forward to seeing you out there in the market.